if two-dimensional array is initialized like int a 2 comma 4, that is a is an array of type integers which stores integers with 2 rows and 4 columns, is initialized to set of 2 sets, and both sets contain element 0. Then option A, first element of each row is initialized to 0. Option B, last element of each row is initialized to 0. Option C, only first element of first row and second element of first row are initialized to 0. And option D, first element of each row is implicitly initialized to 0, while other elements are automatically initialized to 0. Here correct option is option D. This set 0 means first row contains all the elements as 0. That is, first element is implicitly initialized because of this 0, and all the remaining elements in the first row are automatically initialized to 0. And this second set 0 with element 0 initializes first element of second row to 0 implicitly, and the remaining all the elements of second row are automatically initialized to 0. So, suppose if this is 0 and 1, then all the elements in the first row will be 0, and all the elements in the second row will be 1. So here correct option is option D. First element of both the rows will be initialized to 0 implicitly because of these two zeros, and the remaining elements in both the rows are automatically initialized to 0. Here in this question, we have to match the algorithm with the respective recurrence relation. So here if you see a binary search, the recurrence relation would be W. Why? Because in binary search we keep on dividing the sorted list into half. So T of n is equal to T of n by 2 plus 1, and merge sort, here recurrence relation for merge sort would be T of n is equal to 2t n by 2 plus cn. Why? Because here we divide the list into two parts, and after that we combine the list, we combine the result. So here T of n is equal to 2t n by 2 plus cn, and for towers of an I, here T of recurrence relation is T of n is equal to 2t n minus 1 plus 1. Why? Because in towers of an I, the top n minus 1 elements will be moved twice. So here T of n is equal to 2t n minus 1 plus 1. And for quicksort, this is that is T of n is equal to T of n minus k plus T of k plus 1 plus cn is a recurrence relation. So here A is W, B is Z, and C is X, and D is Y. So which is option D? Consider the recurrence relation T of n is equal to 2t n by 2 plus n log n. Then which of the following is correct? In this question, a recurrence relation is given, and we have to express the given recurrence relation in terms of asymptotic notations. In order to solve these kind of problems, we follow Master's theorem, in which there will be three cases. Let us check with case 1. In this Master's theorem, T of n is compared with A into T of n by B plus f of n. So here A is equal to 2 and B is equal to 2, and f of n is L log n. In case 1, we'll check if f of n is f of n order of n power log a to the base b minus epsilon, where epsilon should be greater than 0. So now let us check
if this given function f of n satisfies this condition or not. So here f of n is n log n. N log n is n log n order of n power log 2 to the base 2 minus epsilon. So we can simply say that this condition is not satisfied. So we have to go for next case, case 2. In that we have to check if f of n is theta of n power log a to the base b, and if f of n is theta of n power log a to the base b into log n power k, where k should be greater than or equal to 0. So this condition we have to check. So here f of n is n log n is theta of n power log 2 to the base 2 log n power k. So this here if k is equal to 1, this condition is satisfied. So then t of n will be theta of n power log a to the base b log n power k plus 1. If this condition is satisfied, then theta of n, then t of n, given recurrence relation will be theta of n power log a to the base b log power k plus 1 n. So here this condition is satisfied, then the recurrence relation will be theta of n power log a log 2 to the base 2 is means 1, and log power k plus 1, here k is 1, so log n square. So this is the answer. So here given option, among the given options, option D, t of n is equal to theta of n into log n square. So this is correct option. In the following binary tree, in the following binary search tree, if you delete 20, then the root will be option A 17, option B 25, option C either 17 or 25, option D neither 17 nor 25. So here in this question, a binary search tree is given, and it is given that if the root of that tree is deleted, then what should be the root in the remaining elements in order to make it a binary search tree. Whenever a root is deleted from a binary search tree, then that root can be either the smallest in the right subtree or largest in the left subtree. So here smallest in the right subtree is 25, and largest in the left subtree is 17. So the root of the binary search tree can be either 25 or 17. It can be smallest in right subtree or largest in left subtree. So your correct option is option C. Let strings A, B, C and D are pushed into a stack. After finite delay, they are popped off the stack and pushed onto the second stack. Finally, they are all popped off from the second stack and passed to the printer. In which of the following order the strings get printed? Here first A, B, C and D are pushed into the stack in that order. First A is pushed, then B, then C and then D. This is stack 1. And after some time it is given that they are popped from the first stack and pushed into the second stack. So let us take this as stack 2. Here each element is popped from the first stack and pushed into the second stack. So here first D is popped and D is pushed into the second stack, and then after D, C is the top of the stack. So C is popped and C is pushed. When after popping out C, then top of the stack will be B, then B is popped and B is pushed. into the second stack. After B, A will be popped from the stack 1 and pushed onto the stack S2. So here this is the content of stack S2. So after that they are popped from the second stack and passed to the printer. So after some time these contents of the stack are popped one by one and they are passed to the printer. So first element to be popped will be A to the so A gets printed first. After popping out A, then B will be the top of the stack, then B will be popped out and passed to the printer. So B will be printed after A. After B, C would be printed, and after C, D would be printed. So here the order of the elements in which they are printed is ABCD, which is option